In addition to scatter plots, we can create several other types of plots in R. Two examples are histograms and box plots. Let's first create a histogram of cellular subscribers. To do this, we'll use the hist function. So in your R console, type hist, and then in parentheses, who, $, cellular subscribers. Close the parentheses and hit enter. If you go over to your plotting window, you can see that the values of cellular subscribers are shown on the x-axis, and the frequency of these values is shown on the y-axis. A histogram is useful for understanding the distribution of a variable. Here we can see that the most frequent value of cellular subscribers is around 100. We can also easily create a box plot in R. We'll make a box plot of life expectancy sorted by region. So back in your R console, type box plot, and then in parentheses, who, $, life expectancy, and then a tilde symbol followed by who, $, region. Close the parentheses and hit enter. Then go over to your plotting window. You may need to stretch it out a little bit so that you can see all of the labels on the x-axis. A box plot is useful for understanding the statistical range of a variable. This box plot shows how life expectancy in countries varies according to the region the country is in. The box for each region shows the range between the first and third quartiles, with the middle line marking the median value. The dashed lines at the top and bottom of the box, often called whiskers, show the range from the minimum to maximum values, excluding any outliers, which are plotted as circles. Outliers are defined by first computing the difference between the first and third quartiles, or the height of the box. This number is called the interquartile range. Any point that is greater than the third quartile plus the interquartile range, or any point that is less than the first quartile minus the interquartile range, is considered an outlier. This box plot shows us that Europe has the highest median life expectancy, the Americas has the smallest interquartile range, and the Eastern Mediterranean region has the highest overall range of life expectancy values. If you want to give nice labels to any of your plots, you can easily do so by adding a few arguments. Go back to your R console, scroll up, and then inside the parentheses, type a comma, and then x lab equals, and then empty quotes. We're not going to label the x-axis here because the regions are already nicely labeled. And then a comma, and then y lab equals, and in quotes, life expectancy. Close the quotes, and then a comma, and then main equals, and in quotes, life expectancy of countries by region. Close the quotes and hit enter. If you go back and look at your box plot again, you should now see that there's a nice y-axis label and an overall title to the plot. Lastly, let's take a look at some summary tables. So go back to your R console, and we'll start by making a table of the region variable. So we'll type table, and then in parentheses, who, $, region, close the parentheses and hit enter. This is similar to what we saw in the summary output and counts the number of observations in each category of region. Tables work well for variables with only a few possible values, and we'll see more of this in recitation. You can see some nice information about numerical variables by using the tapply function. Let's start by looking at an example. So type tapply, and then in parentheses, who, $, over 60, comma, and then WHO, $, region, comma, and then mean, close the parentheses, and hit enter. This splits the observations by region and then computes the mean of the variable over 60. So tapply splits the data by the second argument you give, and then applies the third argument function to the variable given as the first argument. This result tells us that the average percentage of the population over 60 in African countries is about 5%, while the average percentage of the population over 60 in European countries is about 20%. Let's look at another example. This time, in the tapply function, will give us the first argument, WHO, $, literacy rate. Then as a second argument, we'll give WHO, $, region again, and as a third argument, we'll give min, close the parentheses, and hit enter. Here we see something a little strange. We have the value NA for all of the regions. This is because we have some missing values in our data for literacy rate. A common thing to do is to just remove the missing values when doing the computation. We need to pass one additional argument, so hit the up arrow, and then inside the parentheses add a comma, and then na.rm equals, and in capital letters, true, and hit enter. This removes all of the countries that are missing a value for literacy rate before doing the computation. This time we see numerical values, as we expect. So we've split the data by region again and computed the minimum value of literacy rate for all countries with a value in the literacy rate variable. By using some basic functions in R, plots, and summary tables, we were able to get a better understanding of our data. You'll see more of this in the recitation and homework assignment.